In this lesson we will be looking at adding and subtracting polynomials. So we really need to make some definitions. First of all, what is a polynomial? It is a finite sum of terms. Finite meaning there's an end, where each term is a number or the product of a number and one or more variables raised to a whole number power. So let's just look at some things of what could be polynomials and which ones are not. Is this one a polynomial? Well, it has three terms, so that's a finite sum of terms. Each term is a number or a product, meaning you have numbers and letters multiplied together, and I have whole powers. So yes, this is a polynomial. What about this one? Well, almost sounds good. The numbers, the powers, finite, but that is a negative number. That is not a whole number power. Whole numbers do not include negatives. So this is not a polynomial. What about this one? Yes, you have four things, numbers, letters, all raised to whole powers, so this would be yes. Now this one's kind of sneaky. This part would be a polynomial, but because it's underneath that square root, it is not a polynomial. So square roots, not a polynomial. This one, we have 1, 2, 3 terms. We have some just constants. Now I know it says sum, but remember subtraction is really the same as adding a negative. So sum or difference is okay. So yes, this is a polynomial. What about this one? No, because you have a fraction exponent. We haven't learned about those yet, but they're coming up. So it's not a whole number exponent. So that would be no. The next thing is, so a polynomial is any amount of them, a finite amount of terms. A monomial only has one term. A binomial has two terms. So we had a couple of those. Well, let's see. Did we? No, we didn't have any binomials. What about a trinomial? 3 terms. Well, this was a trinomial because it had 3 terms. This is a trinomial because it has 3 terms. Now we need to look at the degree of a monomial. It's the sum of the exponents of the variables. All right, so let's take this part. 15x squared y. That's a monomial because it's one term, but the degree would be 3 because we would add up the sum. We would add up the exponents of the variable. So if I just have 4x to the 5th power, this degree would be 5 because it's x to the 5th power. Now that's a monomial, but what if you have a polynomial, meaning you have a bunch of monomials added together? How do you know what is the degree? Well, you just take the highest degree. All right, so we have 15x squared y plus 21xy cubed minus 4. This degree was 3, this degree is 4, and a constant has a degree of 0. So what would be the degree of this polynomial? It would be 4 because it's the highest one. Again, just some vocabulary. Now the standard form of a polynomial, when we want to write our answers in descending order of degree. Sometimes that's difficult and not possible actually. But let's go back to this one. We could write that in standard form by writing it, this comes first because it has degree 4. This would come next because it has degree 3, and then the constant is always last. So standard form, a nice, neat way to compare all of our answers to make them look the same. So, identify each of the following as a trinomial, binomial, or monomial. State the degree of the polynomial. Right, so we have 2 terms. So this is a binomial, just like a bicycle has 2 wheels, binomial, 2 parts. State the degree of the polynomial. Well, the constant is degree 0. That is degree 4. We take the highest degree. This one has 3 terms. So this would be a trinomial. And what would be the degree? We want the highest degree so that would be 2. What's this one? It's a constant, which is also a monomial, one term. And what is that degree of a constant? The degree is 0. Right? That would be like x to the 0 power, and we just learned that in the last lesson, which of course is 1. So if I multiply 7 times 1, I would still get 7. The degree would be 0. Next one, combine like terms, write in standard form if possible. So really a very easy lesson. We did this on the very first day of class, combining like terms. Well, these are alike because the letters and the exponents match, so we would just add the coefficients. 9 plus 2 is 11, and keep your x squared. Then those x's are the same, but what happens? 8x minus 8x, that 0 goes away. And then we have our constants, and that would be minus 7. And that is in standard form because it's in descending order. Look at what I'm going to do on number 5. Because I know I want it in standard form, I'm going to look for the highest degree. So I have x cubed and I have negative 8x cubed. So I'm going to put that together first. That's negative 7x cubed. Then I'm going to look for the x squares. Do I have any? Yes, I do. Do I have any more? No, I don't. Then I'm going to look for the x's. Well, I have some here and here, nowhere else. Put those together. That's a plus 11x. And then any constants, put those together, negative 18. So I could have added them in any order, but again, because I was looking for standard form, I went through and picked out the highest degree first and then descended. Perform the following additions and subtractions. Write answers in standard form if possible. If you have a plus sign between parentheses, that just means you're adding, and there's nothing in front of the parentheses, we can remove the parentheses. We're not changing any signs because we're adding. And now we can combine like terms. Well, let's see. Do I have any? I have 2x squared and a negative 6x squared. So that combines to negative 4x squared. Then I see a negative 3xy and a positive 9xy. So that would be plus 6xy. Then let's see what else I have. I have 4y squared and a negative 9y squared. That is negative 5y squared. Can I write this answer in standard form? No, I cannot. Because what's that degree? 2. What's that degree? 2. Remember, you add the exponents. What's that degree? 2. Since they're all of degree 2, it doesn't matter what order you write this in. I just happen to write it in this order. So again, that's why it says, if possible, on that standard form. Now, number 7. Why do people miss number 7? Because they want to be lazy and not take care of that minus sign. That minus affects everything behind it. It's like multiplying by a negative 1. So this first parenthesis had nothing in front of it, so I'm going to get rid of the parenthesis. Then I'm going to change all the signs in the second parenthesis. Take your time and write that step out. Don't do it in your head. It's just not worth it. Now I'm going to combine like terms. I have negative, oops, those are like, I almost put them together. You almost let me do that. That would be wrong. Those are not alike. One's x squared, one's x cubed. So let's start with this one. That's negative 7x cubed. Then I have 3x squared, and it's positive. Right? Is anything alike? Well, let's see. I have a negative 5x and a negative 1x. That's negative 6x. And then I have a plus 3 and a plus 1. which is a plus 4. And have I written my answer in standard form? Yes, I have. Key thing on this problem is this minus sign gets distributed to everything behind it in that parenthesis. That's all there is to it. But if you have a plus sign, it doesn't change anything. Get rid of the parentheses and then just collect like terms. So let's look at number 8. This time we do have numbers in front of the parentheses, which we've done before. So we're going to distribute. Here I'm going to distribute a -6 and then combine like terms and put my answer in standard form. So I'm going to put my x's together. Then I'm going to put my numbers together. Since they're both negative, I'm going to add and keep the negative. That is in standard form. Again, a very easy lesson.